Okay, in order to determine parallel perpendicular, we need the slopes, right?
Yeah.
So look at the first one. Can you determine the slope of the first one?
Yeah.
What is it?
2/3.
Good. It's pretty clear that it's 2/3. So we're going to say the slope is 2/3. What about the slope of the second one? 3 over 2.
Perpendicular.
So the first two slopes were very easy to determine. The last one, how can I determine the slope of this one?
Figure out y, so you have
Very good. So I'm going to have to solve for y. So I'll solve this one for y. Subtract 2x from both sides. I get negative 3y equals negative 2x plus 8.
a negative divided by negatives are positives, right?
Yes, ma'am. So when I divide those out, I'm going to get y equals
2/3 x
positive 2/3 x
plus
minus, and I do have 8 over 3. Actually, I really don't even care about that, so I'm just going to leave it as 8 over 3. Remember, my whole point was to determine the slope. Can we determine the slope now?
yes.
What is the slope?
2/3 x.
2 over 3. Oops. 2 over 3. All right. Now we can compare some stuff. All right. The first one and the last one are the same, which means those are parallel, right? And the middle one here, well, is it perpendicular?
No.
It's not, because it's not the opposite sign. It is flipped, but it's not a negative flip. So no, those are not perpendicular. So the best answer here is going to be that line 1 and 3 are parallel. And remember, anytime you talk about parallel perpendicular, you have to give me the slopes. So we would say that they both have a slope of 2/3. That's our best answer for this question. Okay, again, our job is to determine whether they're parallel or perpendicular. So as we look to see if they're parallel or perpendicular, we need to know the slopes. So let's look at that first one. So the slope of the first one is 4. That came from right here. Now the slope of the second one, a little bit harder. So what she did was she changed the equation. We're going to have to solve. So we've got minus x on both sides. That leaves us with 4y equals minus x plus 12.
Oh, no, I get what you're doing. I get what you're talking about.
When we divide everything by 4, then that's going to leave us with our slope-intercept form, which is negative 1/4 x plus 3. Very good. Right here, this reads negative 1 divided by 4, so it's negative 1/4. And then, of course, 12 over 4 is 3. So now my slope is, what's my slope? Good, negative 1/4.
So that means lines 1 and 2 are perpendicular.
Okay, I can already tell something about lines 1 and 2. They appear to be perpendicular, right? So I already know that these two are perpendicular.
See.
Now I do have one more.
That's perpendicular.
I do have one more line over here. Let's make sure that we determine whether its slope.
It's y equals negative 4x plus 4.
Okay, I'm going to have to subtract the 4x on both sides. And in one step, I found out that y equals negative 4x plus 1. What's the slope of that?
Negative 4x.
Negative 4. Good. Which means now I can compare it to the rest of them. Is the third line over here, is it parallel or perpendicular to the first?
No.
Neither one, right? It's not parallel and it's not perpendicular. So the third one is not either one. What about to the second line?
It is a.
Perpendicular to the first.
Well, I meant the line 2 and line 3. Line 2 and line 3 are not perpendicular, are they?
No, that's
Because they end up both being the same sign. You have to really watch the signs. So on this one, we can see our final answer. We can see that line 1 and 2 are perpendicular. Remember, that's the symbol for perpendicular.
Could it also be the other way around, like a T instead of an upward?
Because the m's were 4 and negative 1/4. Remember, I do want you to always explain why it's perpendicular, so you have to be able to use the slopes when you do that. So, even though this isn't written correctly, I'm supposed to be perpendicular to this line, and I have to go through this point. Okay? So, it should be through. Okay. So, I have to be perpendicular to this line. What's the current slope of this line? Well, x, so what's the coefficient? It's a 1. Rise 1, run 1, right? What would be the perpendicular slope to a 1? Think about it. You have to flip the fraction. So 1 is really the fraction 1 over 1. So flip it. Yeah, it's still 1 over 1, and then you make it negative. It's negative 1. So the perpendicular slope is going to be negative 1. So now we need to write an equation with this point and this slope. So we're going to go to point slope form. It's y minus y1 equals m parentheses x minus x1. We've been using this for about a week or so.
Okay,
Can you fill in the blanks for me? Sure.
Yeah.
Y subtract.
1, negative 1.
It actually would be positive.
Well, it's actually y subtract negative 2,
2, and then equals,
which is y plus 2. And I know a lot of you are at that point where you can just write that as a plus. And then what's my m?
3, negative 3.
Negative 1.
Negative 1. Parentheses x minus negative 3. And again, that turns into a plus, doesn't it? So, sounds like some of us need to be reminded that that's an x1 up here and a y1 here. Okay. Simplify that. That's y plus 2 equals negative 1x minus 3. And then when you add, no, not add,
Divide.
when you subtract 2 from both sides, minus 2 is the opposite there, then that's going to give you y equals negative 1x, and that's minus 5.
I thought you divided.